Now we're going to go through how to solve logarithmic equations. So these are equations that have logs and the variable is inside the logarithmic function expression. So very similar to exponentials. If convenient, express both sides as logs with the same base, then set the arguments equal to each other. So the thing inside the logs equal to each other. So here we have natural log of 4x plus 10 minus natural log of x plus 7 equals natural log of x. Now, right now, we kind of have two log expressions on the left-hand side, and we need to change that to 1 before we can set anything equal to each other. And what we can do is rewrite this, use our rules about logarithms. And remember, for subtracting two logs, we can make it one log where we're dividing. So this can become natural log of 4x plus 10 divided by x plus 7 equals natural log of x. Now that's just one log with the same base on either side. We can set the arguments equal to each other. So we can say 4x plus 10 over x plus 7 equals x. And now we're going to solve this rational equation. So the first thing I'm going to do is multiply both sides by x plus 7. So here they'll cancel out, and we'll have 4x plus 10 equals x squared plus 7x if we just go ahead and distribute that x. Next I'm going to subtract 4x from both sides, and I'm going to subtract 10 from both sides so we get everything on one side. So I'm going to have 0 equals x squared, and then 7x minus 4x will give us 3x minus 10. And that we can factor this, right? That will factor as x plus 5 times x minus 2. And if we set each of those factors equal to 0, we get x equals negative 5 or x equals 2. Now the only thing we want to check is that these work with the original equation. Like we did with radical equations, we could actually get extraneous solutions here. And if we look at negative 5, if we plug it into even the right-hand side in this equation, natural log of negative 5 is undefined. Remember, the domain of natural log is positive numbers. So not negative 5 isn't in the domain, doesn't work. 2, however, 4x, so 4 times 2 would be 8 plus 10, that's positive, so we're okay there. 2 plus 7, 9 is positive, and then 2 would be positive. So our only solution here is x equals 2. Okay, now this next one should be written as log base 4 of x equals negative 2. And here we don't have a log on both sides, so we need to use the second method. It says otherwise rewrite the log as an exponential equation. And that's why we did so much practice going between logarithmic equations and exponential equations. So we're going to rewrite this as 4 raised to negative 2 equals x. Now you can see x is just equal to 4 raised to the negative 2, which is 1 over 4 squared, or 1 over 16. So x is equal to 1 over 16. Okay, number 3 here we have log of x plus log of x minus 3 equals 1. So the first thing I'm going to do is write it so that we just have one log. Here they're both log base 10, right, since it's just log. And x times x minus 3, or sorry, x and then x minus 3. So since it's a plus in between, we can change it to one log, and we're going to multiply x minus 3 equals 1. Now remember, this is log base 10, so when we rewrite it as an exponential equation, we're going to have 10 to the first power equals x times x minus 3. And we want to solve that equation. So we're going to distribute the x. We'll have 10 equals x squared minus 3x. We're going to subtract 10 from both sides, so we get everything on one side. So I'm going to have 0 equals x squared minus 3x minus 10. This is going to factor as x minus 5, x plus 2. So I'm going to get x equals 5, x equals negative 2. Now again, remember with logs, always check your work. If we plug 5 in, we'd have log of 5, log of 2. So there, nothing, we don't get anything that's undefined. So 5's okay. If we plug in negative 2, well, the very first one we'd have log of negative 2, which is undefined. So negative 2 can't be a solution. So we would just have log of 5. Okay, now this right here should be log base 7. Base 7. So here we have log base 7 of 2x plus 7 minus log base 7 of x minus 4 equals 1. So first I'm going to rewrite it as 1 log base 7 of 2x plus 7 over x minus 4 equals 1. And now we're going to rewrite it as our exponential equation. 7 to the first power equals 2x plus 7 over x minus 4. So I'm going to multiply both sides by x minus 4 to clear this denominator. So that would be 7x minus 28 equals 2x plus 7. I'm going to subtract 2x from both sides. That would give me 5x minus 28 equals 7, and I'll add 28 to both sides. So 5x equals 35, and then we'll divide both sides by 5, x equals 7. And we do just want to remember, check to make sure we're not violating any domain rules. So if we plug 7 into the argument, we'd have 14 plus 7 is 21. It's positive. And then here 7 minus 4 is 3. It's positive, so we're okay.